When architecting a new Amazon cloud application, one of the first design decisions is about our VPC, the structure of subnets, route tables, network ACLs, and security groups. From what I have seen, and I hope you would agree with me, that we tend to jot down design decisions in a spreadsheet like document, and then we come to Amazon Console, right? And start doing something like this rather quickly, which I think isn't the best way about setting up our VPC architecture, because a small typo or a minor configuration error here can lead to serious implications, including the redesign of our VPC down the road. So, what should we do? Well, I'm recommending doing something like this instead. That is, visualize the entire architecture with all of its components, including subnets, custom route tables, and associated rules, all of our security groups and associated inbound and outbound traffic rules, all of our CIDR block schemes, and elastic IPs, as well as workflow and communication between various components. And once that's done, I think taking this information over to our CloudFormation or to our console, I think is rather a straightforward exercise. So let me show you what I mean by visualizing such a design. So here I'm visualizing having a VPC with this default CIDR block scheme within Amazon Cloud, with a router and an internet gateway, as well as having a couple of elastic IPs so that we can associate those with our NAT gateway and also with our web server, which are within our public subnet, for which we are using this default CIDR block scheme. Next, we are going to visualize having a private subnet to house our app server, right, with this CIDR block. And this app server is having this private subnet with no external IP associated, because as you know, app server shouldn't be talking to internet directly. Next, we are visualizing having yet another private subnet with this scheme, and this is going to house our database instance or database service with this private address. Next, we should depict our custom route table. Here I'm showing two simple rules. The first one, as you know, is allowing instances within this VPC to talk to each other. The second rule is limiting any subnet traffic going to the internet via the internet gateway, right? Because this happens to be our public subnet. The next route table has again two simple rules. The first one is similar to this, but the second rule is forcing the rest of subnet traffic to go through NAT gateway service, right? Because this route table is going to be associated with our private subnets. Next, we need to jot down all of our security groups and the associated inbound and outbound traffic rules. And finally, associate or link this security group with our web server, right? So here I'm opening these inbound traffic rules, these two outbound traffic rules, and third one is very specific so that web server and app server can talk to each other. So for this security group, which is going to be associated with our app server, we'll have an inbound rule again on port 8000. Plus, we are going to allow some outbound traffic so that we can update our app server, say with the latest binaries and patches. We are also opening this outbound port on this security group, assuming that we are using MySQL as our database service. For this security group, again, we are opening this as our inbound traffic rule. And I think that completes the entire visualization exercise. And once that's done, again, like I said, translating this information over to this console is, I think, pretty straightforward. So let's do that. Well, before going there, we need to block a couple of elastic IP addresses, which I have already done in advance. So let's go to VPC dashboard and click on this wizard and select option number 2, because in our exercise we are having one public and two private subnets. So I think this is our best bet. Select and give it a name. Excuse me. I'm leaving the rest of these values to their defaults and make sure this is matching with our design. And for NAT gateway, associate one of the elastic IPs, and here we can create our VPC now. So while it's going on, it might take a few seconds. I wanted to point out a couple of things that I forgot earlier, and that is that it's a good practice to elaborate these rules further with appropriate comments. As an example here, for this security group, I'm talking about all of our inbound rules with appropriate comments, and as an example, port 22, which allows SSH access, should have a proper source written down. So if you're opening these ports, or rather allowing traffic to come from your office or home office, I think we need to jot that down in the CIDR block format. For outbound rules, for port 8000, remember the destination is the ID of our app server security group. Similarly, if we go to our app server security group, right, the source has to be the ID of our web server security group, right? And that's how port 8000 allows a two-way communication between web server and our app server, right? So I just wanted to point that out. Now going back, I think our VPC is almost created, and hopefully it's available right away. And if it is available, let's actually review our subnets, right? We are supposed to have 3 subnets, and I think we already have 2 created as part of our VPC wizard exercise. we just need to create third one. But before going there, we need to make sure CIDR blocks are matching with our script 0010 0010, and third one has to be 2.0. So let's just quickly create db private subnet correct VPC and with correct CIDR block, and this will allow us to have 251 odd IP addresses, which is a lot for this exercise, but I think it helps us understand the mechanism of doing these things. So going back, I think we have our subnets created. Next, we need to figure our route tables, and hopefully we should have two route tables already present, right? This one is main, so this must be custom, or rather, let's make it custom. First, I'm going to give it a name, say custom route table, and then review entries. This one is, I think, matching with our intended rule set. The second one should point to the ID of our internet gateway, which is the case, so it's all good. Make sure that these rules are associated with public subnet, again, which is the case. Going down the road, now here again, first let's put something meaningful and review entries. This looks good, and this must point to the ID of NAT, which again happens to be the case, and make sure that this main route table is associated with two private subnets. And once that's done, I think we can quickly move to security groups. So first security group is called web server security group, with these three inbound and these three outbound rules. Excuse me. So going to here, well, this one came default, so for now I'm going to not care much, but create my own. So let's do that. Select the correct VPC and create three inbound rules, right? On 22, one on 80, and one on 443, and source, well, remember this is SSH access, so source should be very limited to either our home office or work CIDR range. So I'm going to just pretend that this is that range and limit access from there, right? And as far as port 80 goes, I think web server can expect traffic to come from anywhere on both of these ports. And as far as outbound rules go, we need to have, again going back to our cheat sheet, outbound has to allow traffic going to the ID of app server security group and these two regular outbound ports. So again, going back, creating a custom rule on port 8000. This one should be the ID of our app server security group. But for now, let's just leave it there. Add another rule to match our design. So open port 80 and then port 443, right? And once we do that, we need to save. And then now let's create our second security group, which is app security group. Make sure it's matching the name web app. Actually, it's always a good practice to do this and go back and do this. Select the correct VPC and remember to review the inbound traffic rules. So here we need to open port 8000 on inbound traffic rule. So let's do that, and it must be the ID of, yes, you're correct, of our web server security group. And on outbound traffic rules, we need to limit outgoing traffic to actually on these ports, right? And why we are opening these ports, because from time to time we may need to patch our app server, right? And because of NAT rules, this traffic will go through our NAT server. So hopefully this is okay. Inbound should be on 8000, outbound, okay. Now let's create our last security group. Within correct VPC, and this security group should have only one inbound rule, right, on 3306, and the source should be our app server security group. Save it. And I think I forgot to put 3306 on here. So let's do that quickly. Outbound traffic should have a custom rule allowing app server to DB server communication, right? So this app server should be pointing to DB server related security group. So let's do this save and quickly revisit the web server. It has been a while since we created this. So inbound from home office and outbound is limiting, and this one now we need to revisit and fix this. On 8000, web server should be speaking with app server. So let's do this and save, and I think we are done with all of our security groups and the associated traffic rules. So lastly, I'm going to show you quickly how to create a web server and associate that with this security group, right, and assign this web server an elastic IP. So quickly moving back, jumping in here, let's launch an instance, select a freebie one, and make sure, since we are creating this instance in our public subnet, make sure it is selected, and later on we are going to assign this a fixed elastic IP. I'll select my default IAM rule and I'll say review and launch. And we have another chance to review our security groups. So let's do that. And remember, we need to associate this web server with this security group, right? So that all of our inbound and outbound traffic rules will be honored. So let's do that, review and launch. I think we can launch now. And finally, going back to our second elastic IP, right? Now we can associate, well, this one is already taken by NAT gateway, but this one is available. So let's do this, associate this with the instance that we just created and associate. Oops, I guess I must be selecting the old instance. Let's try again, or maybe it's getting launched, and try again. Yep. So now we have our web server ready to go. So going back, let's quickly review that. The web server instance has the correct public IP address, which is the case, and it is mapped to an internal IP address here. So I think it looks all good, and that's all I wanted to cover in this session. I hope this was somewhat useful, and if it was, please give me a thumbs up. But if you have some critique or comments or feedback, feel free to send me an email at this address, and I'll try my best to respond as quickly as I can. Thank you for watching. Please take care. Bye-bye.